Hello guys, welcome back to my YouTube channel Biomathematician. Today we will be discussing about range and interquartile range. So before moving forward, first we create the dataset, a dummy dataset. So this dummy dataset will follow a normal distribution with the mean of 0, standard deviation of 3 with 1000 data points. And this data is will be created as this case, as we can see that I have rounded out it to 0 with the integer data type. So we have normal distributed data with 1000 samples with a mean of 0 and standard deviation of 3. So we create the dataset. Let's explore it. So our dataset should be a discrete value. So we first explore. So here you can see that the data is of discrete value. It is not continuous data and represent integers here only. So let's see whether the data is correct or not. So it should have a mean of 0. So let's see. So its mean is around 0, which is correct. Then standard deviation should be around 3, so which is also okay. So hence we can move forward. So let's discuss about range. Range is in statistics refer to the difference between the maximum and the minimum value in the data. It is a measure of variability or dispersion of the data. Range is very commonly used in statistics to define the variability of the data, and it is very intuitive to infer and easy to calculate, as we will see. So let's calculate range for the above dummy dataset. So for that we have to get the max value of the data from the data, that will be using max function, and minimum value of the data within the data using the minimum method. Then we will calculate range by subtracting maximum value by minimum value. So our range is 18. So what does this 18 means? So let's plot the data. So our data follows the normal distribution, so it has the bell-shaped graph, which is obvious, and then we can see that the majority of the data point lies in the center, as which is common for normal distributed in data, and here is the range. So range represents the spread of the whole data set. So range represent the interval between the minimum value of the data to the maximum value of the data. So it explains the spread of the data with respect of the outlier. So if you incorporate the outlier here, it will expand to here also, here also, here also. The more outlier you add, it expands a lot. So it is very sensitive to outlier, as this is the reason. This is one of the limitation for the range. So it is very susceptible to outlier. So let's check it out. So for that we will add an outlier to the data. Our outlier is 100. So let's check if our outlier is there or not. We will print the last item within the data. So that is 100. So our outlier is there. Let's calculate the range for the same. Next function we will use So the range of the data is 109 now. So as you can see, just I have added one outlier and its range have been drastically changed from 18 to 109. So range is very sensitive to outliers, so it should be kept in mind while doing the using this as a measure of variability, that whether the data has outliers or not, or if the data has outliers, that outliers should be removed and the data also follows a normal distribution as well. Our second measure of variability is interquartile range. So interquartile range is commonly used with median. So median is used as a measure of central tendency, and then it is used with interquartile range to explain the data. So interquartile range is calculated by subtracting 25th percentile from the 75th percentile of the data. So it denotes or expresses that 50% of the data. It denotes the variability of the 50% of the data. So for that we need to have k, that is percentile. So if we want to calculate 25 percentile, that is quarter 1, it is here k will be 25, and n is the number of observation within data. If n divided k, n plus n into k divided by 100 is an integer, then kth percentile will be the average of these two values, nk divided by 100 and nk divided by 100 plus 1. Otherwise it will be the j plus 1, where j is the largest integer, which is less than nk divided by 100. So let's calculate interquartile range using our own defined function. So for that we will make a function. We will and within the function we first sort the data in increase of order, then we can calculate n, that is the number of observation. Then if a number of observation, if nk divided by 100 is an integer, then we will just put the same formula in here, but there is a trick that we have to minus it by 1, as Python follows the zero indexing. So for both we just minus it by 1, and then if it is not an integer, then it is just n into k divided by 100 minus 1. So using the int method, if it will automatically be the j plus 1 observation, which is less than nk. So if we have 3.9, so using the int method it will convert it to 3, which will be j plus 1. So let's calculate the interquartile range for our data using our user defined function. So for that we will first calculate quarter 1. Quartile 2, quartile 3, sorry, and then interquartile range will be quartile 3 minus quartile 1. So our IQR here is 4.0. Let's do the same using our numpy method. Using the numpy library. So numpy has a function that is percentile, which we will use here. So it is a predefined function which comes with numpy. So let's calculate IQR using numpy. For that we first import numpy, and from that we will calculate. And IQR will be quartile 3 minus quartile 1. So here also our interquartile range is 4.0. So what does we mean when we say interquartile range? So let's see it visually. So this is quartile 1, uh, and before that the data points here all consist of quartile 1. Here this post this vertical line is quartile 4, and within quartile 4, and between this is our quartile 2 and quartile 3, that is consists of 50% of the data. So you can see that it doesn't consider the quartile 1 and quartile 4 data, that is 50% of the data having the maximum number of variability. So it only gives the variability of 50% of the data, central 50% of the data. So it is less prone to outliers, as if outliers will be here and here, it will not be kept in consideration while calculating the interquartile range. So let's check it out if that is correct. For that, we will add an outlier to our data. So this time we will add a heavy outlier, that will be 200, and let's check it out whether this affects the interquartile range or not. Quartile 1 will be quartile 3 will be and interquartile range will be quartile 3 minus quartile 1. So let's check it out. So here you can see that interquartile range has not been shifted, and it is still 4, which have been using the NumPy percentile method and using our predefined method also. So interquartile range is not sensitive to outliers, as you can see here. It didn't change even after adding a heavy outlier, that is 200. So apart from its advantage of not being influenced by the outliers, there have some limitations for interquartile range also. So interquartile range considers only 50% of the middle data set. So it is somehow biased toward it, and it doesn't consider the whole data, so it doesn't explain the variability of the whole data. So that is one limitation. Second is it doesn't have any didn't have any SI unit, so you cannot be intuitive about what specifically the value denotes. So that is the problem with that. So in range you can if you know the starting of the data and range of the data, you can predict what will the end of the data. But with interquartile range, that is the problem, because we have no idea about the extremes value, so we cannot be sure about what exactly was within the data. So this data can just be adjusted to between the two quartile, and it can spread more. Still, we will not have the exact idea about the spread of the data. So that are few limitations about it. Apart from that, it is very commonly used in median to explain the variability of the data, and this median as a central tendency of the data. I will attach the link for this Jupyter notebook within the description. Please find it from here, and you can play more with the data and perform further analysis accordingly. Thank you.